Hey class, this is Mr. Roberts, and I am gone for at least another day. I've given you an assignment with I think 15 problems, and I just wanted to talk about a couple of them because this is something that we touched on, but I don't think we've practiced a lot. So in this question, you're asked to find the measure of this angle here that's labeled with the question mark, and I think they'll all be labeled with the question marks, the one that I want you to find. And we're going to use our three trig ratios that we've been talking about and using to write an equation that'll help us find this angle labeled with the question mark. For this particular problem, if I look at it, if I'm trying to find this angle, the angle labeled with the question mark, and I notice I have the following values. I am given the side that's opposite, and I'm also given the length of the side, the leg that's adjacent. Well, the one trig ratio that uses both opposite and adjacent is the tangent. The tangent of this angle labeled with the question mark, right? The tangent of that angle is opposite, which is, the tangent's always opposite over adjacent. But for this case, the opposite leg is 5 and the adjacent leg is 11. Now, that's great, but it doesn't give me what the angle is. That just gives me what the tangent of the angle is, right? The tangent of this angle I'm trying to find is 5/11. The question is, what's the angle? Well, to find the angle, we need to use the inverse function, the function that undoes taking tangent. And I'm going to bring my calculator over here. You guys can use these, just make sure they get back up on the rack. All of them should be there except for the one on the lower right. If I want to find this angle, the first thing I want to make sure is that my calculator is in degree mode. So right here there's a mode button, and I don't know that you can see this, but it's right next to this blue button that says second. I don't think you can see my pointer on the screen, but what you're going to do is hit this mode button and make sure it's in degrees, and you can see this calculator is not in degree mode. So I'm going to go down, down, I'm going to go over. Once my cursor is flashing on degree, I'm going to press the enter button that's down almost at the bottom of your calculator on the right. Press enter, and now you can see that is the box that's highlighted, right? It's the one that's got the dark box around it. So you can see I am in degree mode now. So now I can hit second and quit. So you should only have to do that once with the calculator, just verify that it's in that mode. So if I'm trying to find the tangent, if I'm trying to find this angle, right, what I'm going to do is I'm going to use the inverse tangent. So I'm going to say, hey, this angle, and watch how I transform this, right? Watch how this equation transforms. This angle is equal to the inverse tangent of 5/11. So in order to find this angle, I'm going to enter on my calculator. I'm going to hit second, inverse tangent, and then 5 divided by 11. Close the parentheses and press enter. And it says that it's 24.44. Now the instructions on this say find the angle to the nearest degree. So if I was rounding to this to the nearest whole degree, I would have to say that this particular angle is 24 degrees. Okay, let's do one more of these. Let's jump down and do number 7. And number 7, again, we're finding this particular angle. And you can see this time I don't know the opposite side, right? What I do know is that this is clearly the hypotenuse. And in terms of my angles, or the sides, this is the adjacent leg. It's the leg that's touching this particular angle labeled P. And again, like I said, I don't know the opposite side. Well, for my trig ratios, the ratio that was opposite, that used hypotenuse and adjacent, I'm just going to write this down just as a memory aid. The sine is the opposite divided by the hypotenuse. The cosine is the adjacent divided by the hypotenuse. and the tangent is the opposite divided by the adjacent. So I have hypotenuse and I have adjacent. That looks like I'm going to be using my cosine ratio. So the equation I'll write is that the cosine of this angle that I don't know is equal to adjacent side is 51 divided by the hypotenuse 54. Cosine is 51 over 54. So if I solve that, that means that to solve this, remember the pattern that I showed you, we're going to take the inverse cosine of both sides. When I do that, this becomes just my angle, and over here I have the inverse cosine of 51 over 54. So I can use this to find what that angle is. So let me bring the calculator back up here again. Again, I'm just going to press clear. And I'm going to hit second, and this time I'm using the inverse cosine of 51 divided by 54. And when I do that, I get that to the nearest degree, this is 19. So this angle is 19 degrees. That's my answer. Okay, and the last problem I'm going to do is it's a little bit different than the first two. Let's go down to question 11. In question 11, you're asked to find one of the side lengths, and you're given an angle in another side. So if I'm looking at 11, I can see clearly that I have, this is the relationship between these three things is with the tangent ratio, because the tangent is the opposite leg divided by the adjacent leg. So I can write here that the tangent of a 17 degree angle, tangent of 17 degrees, is equal to opposite x over adjacent 13. So if I was going to solve this equation for x, I can see x is being divided by 13. So to undo that, I could multiply both sides of this equation by the number 13. I'll write it as 13 over 1 here, and just 13 here. So if I simplify right on the right hand side, because I now have a factor of 13 in both the numerator and denominator, I'm left with just x. And on the other side, I have 13 times the tangent of 17 degrees. Well, I'm ready to go. This time I'm not going to use the inverse tangent because I know what the angle is at 17 degrees. I'm just going to use the tangent ratio. So I'm going to enter 13 times the tangent of 17 degrees and press enter. And I get to the nearest, it says to the nearest tenth. So if I'm looking at 3.97 and I'm rounding that to the nearest tenth, that 7 is going to kick up the 9, and therefore that's going to have to a 10, so that's going to have to kick up to the ones place. So to the nearest tenth, x should equal 4. Let me write this down here. I'll write x was approximately 3.9744. And if I'm asking you to round that to the nearest tenth, this is the nearest tenth place. It would definitely round up. And when it does that, this 9 is going to become a 0 and the 3 would become a 4. So my answer is, to the nearest tenth, x equals 4. Again, I hope this is my last day gone. I hope to see you again tomorrow on Thursday. Good luck with this assignment. Please continue to help each other, be nice to each other. I'll talk to you later.